Okay, EG6. A junior gymnastics league is open to children who are at least 5 years old but have not yet had their 9th birthdays. The age X years of a member is modelled as a uniform continuous distribution over the range of possible values between 5 and 9. Age is measured in years and decimal parts of a year rather than just completed years. Find the probability distribution function fx of x. So it's a uniform continuous distribution between 5 and 9. So x is uniform 5 and 9. So if we sketch that, then that is 5, that is 9, difference is 4, so that's a quarter. So that means that the probability distribution function fx is a quarter for x being between 5 and 9, and 0 everywhere else. So that's the probability function, distribution function. Part B, I want the probability that x is between 6 and 7. What's the chances that the age of the gymnast is between 6 and 7? So if I consider that on my diagram, I'm interested in this area here. Well, the area of that is going to be total probability less the area of this, which is 1 times a quarter, and the area of this, which is 2 times a quarter. So that's 1 minus 3/4, which is a quarter. So the probability that the age is between 6 and 7 is a quarter. C, I want the expectation. Well, the expectation is 5 plus 9 over 2. So that's 7. Variance would be 1/12 b minus a. So that's 4 over 12. Sorry, squared. So that's 4/16 over 12, which is 4/3. So that's all pretty standard. Then part E, the percentage of the children whose ages are within 1 standard deviation of the mean. So standard deviation, from your AS work, you should remember that standard deviation is the square root of the variance. So that's that. And we want it to be within 1 standard deviation of the mean. So if we go back and think about what we're working with here, there's our rectangle. We know that the mean is 7. So to be 1 standard deviation within 1 standard deviation of the mean, that means you've got 1 standard deviation that way and 1 standard deviation that way. So I want the ages probability to be within that region. Now we know that the height of this is a quarter, and we know that the total area of that rectangle is 1. So as a percentage, I want the area of that pink part, which is going to be 2 standard deviations times a quarter, and as a percentage I want it out of the whole rectangle, which I know has got an area of 1 times 100. So on my calculator I've got the standard deviation is square root of 4/3. So square root of 4/3 times 2 times 1/4. So that's going to be divided by 2 or times 1/2. Oops, hold on. That's gone inside the times 1/2, and then divided by 1, and then times it by 100 to turn it into percentage. We've got 57.7%. So 57.57%, sorry, of the children's ages with that distribution will fall within 1 standard deviation of the mean.